Hey folks, Pete Brady here, and this is on standard normal calculations for statistics. But first, let's take care of this board problem here. All right, in a stats class with 136 students, the professors record how much money each student has. So the histogram that you drew in the prior lesson, board problem 9, is the collection of the data there. So the question is, what percent of students has under $10 is closest to? So is it 30%, 35%, 50%, 60%, and 70%? All right, so here's that histogram that you guys wrote down from board problem 9. And then what I would like to do, we're interested in this bar right here. So this is my under $10. So I just calculated, it looks like this goes up to about 63, I suppose. This one goes over to about 43. I'd say about 20 on this one. And so I wrote the heights up here, and then I added all those up. So when I add them all up, I got 136. So, you know, the fact that this is, it has a little bar right there, I'm assuming it's 1. Same with this dude out here, this outlier right here. So 136. So I take the number of people that have $10 or under, which is 63. 63 divided by 136, and I get about 46%. So let's look at our choices again. And the one that gets closest to 46%, to me, I'm getting 50%. I don't know how the book gets 35% unless they interpreted the under as being closest to or under. So anyways, I got choice C on that one, okay? And if you're in my class, today is Wednesday. We're going to be having a notebook quiz soon, so in a couple of days, okay, our first one. So here we go, standard normal calculations. Okay, so because all normal distributions are the same, when we standardize, we can find the area under any normal curve. We're using table A on the inside cover of your, the front cover of your book. So get your books out, you guys. All right, and I'm pulling my book out right now, and I'm just opening it up to the inside front cover, and you see table A right there. And if you look down the left-hand column, you see your Z's. So your Z's go from negative 3.4 to negative 3.3. And then if you're with me, guys, open that book, excuse me, and then go negative 3.3, and then go over, let's go over 4 columns, you guys. 1, 2, 3, 4. I get 0.0004. Okay, that's at negative 3.33, because up above it you see 0.03, so that means negative 3.33. If you don't have the book in front of you, it's any standard normal z-score table would get that for you guys, okay? So if you don't know statistics, you don't know what I'm talking about. Anyway, so the standard normal distribution has mean 0 and standard deviation of 1. So we say normal with the n, mean 0, standard deviation of 1 right there. Okay, so if a variable x has any normal distribution with normal with mean mu, because remember we had the girls, which was 64.5, I think, inches tall, and the standard deviation was 2.5, then the standardized table can be used in the front of the book right here. So what we do is, since the front of the book is a z-score table, it standardizes everything. We do x, the number that we're focusing on, minus the mu, which is what's given in the problem, and divided by the standard deviation of the problem. Okay, where z is the number of standard deviations above or below the mean. This will seem vague until we get further in. And x is the number you're focusing on, so z comes from table A. All right, so let's try some of these. The height of women are approximately normal with the mean height of 64.5 inches and standard deviation of 2.5 inches. Find the number of standard deviations above or below the mean of women with each height. So here we go. So 68 inches tall. Now notice it's normal, 64.5 and 2.5. Okay. So we got to find the z-score of this. So this is my x. So my z-score is just going to be, I'm going to plug in x minus the mu divided by the standard deviation. Here's the mu, here's the standard deviation, and this is the x. All right, so I get 1.4. So since it's positive, 68 inches is 1.4 standard deviations above the mean. Okay? All right, so remember, z is how many standard deviations? Okay, 5 feet tall. Well, 5 feet tall is 60 inches, you guys. So x is my 60 this time, minus 64.5 divided by 2.5, and I get negative 1.8. So it's negative, so that means it's below 1.8 standard deviations below the mean. All right, So, and note that just means standard deviations. Okay, so this exercise is 2.19 on page 95 in our textbook. So the SAT versus the ACT. Eleanor scores 680 on the mathematics part of the SAT. The distribution of SAT scores is referenced a normal population with mean of 500 and standard deviation of 100. Okay, Gerald takes the ACT and he scores a 27. ACT scores are normally distributed with a mean of 18 and a standard deviation of 6. So find the z-scores for both of them and who scored higher. Okay, so whichever z-score is higher. Okay, so here's Eleanor. It's normal, and they said the mean was 500, standard deviation of 100, and she scored 680. Here's Gerald's normal test with standard deviation, and he scored 27. Going to use this formula on both of them and see who got the higher z-score. Okay, so here's Eleanor. She gets 1.8 standard deviations above the mean. Here's Gerald. He got 1.5 standard deviations above the mean. Since Eleanor's is higher, she scored higher. Her score is considered higher. Okay, the table A entries for each z-score represents the area proportion under the curve to the left. It's to the left of the z-score. So if you open up your book again, it's to the left. You see it to the left. All right, so let's try some of these. So there's table A. This is pretty much the picture on the inside cover right there. Let's try some of these. Find the proportion of observations from women 60 feet tall to 68 inches tall. Well, we found a z-score for this one. We found a z-score for this one just a little bit ago. So I just moved it up. So the z-score was negative 1.8 and 1.4. So negative 1.8 is right on the inside cover. Go down to negative 1.8, okay, and then scroll over to the first column. That's negative 1.80. Okay, I see 0.0359. And then turn the page for the positive. So turn the page over and go down to 1.4, and it's 1.40, so I get 0.9192. You guys with me? All right, so there they are right there. All right, we want this right here. We want that in the middle. They want to know in between. Remember, the book always gives me to the left. So to the left of negative 1.8 is that value. To the left of 1.4 is that value. So I want this data in the middle, so I subtract those two. So there's the proportion. Proportion is just a decimal answer, 0.8833. All right? Okay, so find the proportion of data on a standard normal curve that are greater than negative 2.15. Okay, negative is on the when you just open up your book, so go down to negative 2.1. All right, go down to negative 2.1, and then you got to scroll over to the column of 0.05 above. Negative 2.1, and then scroll over, I see 0.0158. Do you guys see that? Okay, so we want above though, you guys. We want when it says that are greater than, we want this side. Your book gives you this answer right here. Remember, the whole curve is 1, or for 100%, 1.00. So I'm going to do 1 minus this 0.0158, and that'll give me this side over here. All right, so you get 0.9842. All right. Okay, scores on the SAT verbal tests in recent years followed approximately the normal distribution of 505 with standard deviation of 110. So how high must a student score in order to place in the top 10% of all students taking the SAT? All right, well, the top 10% is this right here. Remember, the textbook, the z-score only gives me to the left. So to the left of the top 10% is 90%. So remember, my z-score I'm going to look for, or this is my z-score is 90%, because the book always gives me to the left. All right, so we need to have look for the one that's so you got to look in the big body and find the one that's closest to 0.90 for your z-score. Okay, so when I look in there in the body, because it's 90%, this is my area. This is the area right here. So this is my z. Which one gives me 0.90? And my z-score of 1.28 gets me closest to 90. Go to 1.2 all the way over to 8, and it looks like 0.8997. So that's the one that's closest as 1.28. All right, so that's what goes in the z position, and we're looking for x. It's asking what x score will get me that. So I'd cross multiply and plus plus 505 to both sides, and so you get 645.8. So a student must score at least a 646 to place themselves in the top 10%. All right, that's probably enough. I probably boggled your brain a little bit. If you're in my class, that would be your homework assignment. Don't forget you got a notebook quiz on Friday. Looks like this is a short chapter also. Let me just open something real quick, you guys. I only think I have one more lesson, so I'll teach that to you, and then we got a review for a test, and then a test. Alrighty? Okay, let me cancel that there. Oh, I guess that's it. So the review is next. So we got a test in a couple of days too, you guys. Okay, you guys, take care. I'll see you later.